Okay, I thought we'd take a break from the tutorials. I'd like to have sort of what I call a XCode 101 class, and want to talk about variables, objects, outlets, actions, and scope, and so forth. You've seen things in code. Just gonna get rid of these here for now. You've seen this declared, right? Let me go just back for a second. There we go. It's a class. To prove it's a class to you, it's an end-string class reference. Well, what does that really mean? An integer, for example, is a type. So what is the difference between a class and a type? Well, a class has methods, methods about it. And we saw this with a lot of the code in which we wrote. We had the string appending, which was one of the methods we used. We had the initialize and the allocate and so on. Not just in the string classes, but in the mutable array classes, for example. That's a class reference. Notice these are all classes. If I come up with a bool, a boolean is a type over here. A float, which is a floating point, or you can have things after a decimal place, but they're fixed, is a type. Okay? And a double is really the type of no help on this one though. A double, which is a correct double here, has you can have a decimal point and things after that decimal point, and that isn't fixed. You can be out as far as you want. There's another type of integer called an unsigned integer. It's a type as well, but it's an unsigned integer. Alright? And this one we typically use when we need an integer without, of course, as you say, sign. So anytime we have a type or a class, they're very different variables. This one here has methods, this one does not. To bring this into perspective better for you, right? Whoops, sorry. There we go. I'm going to declare the property non-atomic. Let's say read only. Read write doesn't matter. And we're going to use this whole shebang here. Whoops, I lost it there. Copy it. There we go. Place it over here. And we're good to go. Okay. Read write is one of the ways of looking at the variable you declare. We could have done it a read only as well, and that's fine. Interestingly enough, if we do it a retain, look what happens. We get this error message saying property with retain attribute must be of object type. Not of type in the sense of object type, but the object type must support the retain attribute. And because with an integer we aren't going to retain it, we don't. If you recall, with a string, we could retain it, we could release it. With an integer, you don't release it, therefore you can't retain it. That's a better way I want to say it. You also can't, let me see, copy, we can't copy as well, because these things would require it to be released. Alright, but we can assign. That one's certainly possible. And of course, a read-only will work as well. On a string, we could use any one of these attributes for the type of variable. One we retain, one we read-write, one we read-only, copy, and so on. With an integer, because we don't release it, we cannot retain it nor copy it. So an integer doesn't require that. Alright? I'm just going to leave this as read-write just for a moment. Okay. Now, another thing that's interesting here. Notice, the integer is declared within the braces of the interface statement. It says, okay, we have an interface of detail view controller, that's a UI table view controller, and here's our declarations. What does that mean to you? Well, it means that this whole class, anywhere in this class, this integer is accessible. So, if I started typing here, I'm sorry, there it is, there's our integer. It's accessible. Now watch this. What would happen if you did something like this? Well, at first it's going to flag you with a warning here saying it's unused variable. We've seen that numerous times. We've declared it but not used it. Watch this. We'll assign it a value. We get another warning here, which makes almost no sense. Why would we get another one? Local declaration of test string hides instance variable. What it's telling you is, look, you locally declared the integer here, but you hid this instance. So don't do it. There's no point in doing that. What we could do, which is better code, alright, create another variable here and say, right, test string 2 equals test string. And that would be perfectly fine. Notice the difference in the two variables. Notice the color of this one and this one. We have a bluish here because it's a variable, and this is just black because it's declared within the scope. This variable here only exists within the viewDidLoad method. This one exists within the whole class. Don't believe me? Take a look. The variable, the properties, the setter, or rather the getter and the setter. They're here. The setter and the getter are part of the property declaration as well as the property, and the variable is here. So what it's telling you is that this variable is within the scope of the entire class. I could pick it up anywhere I want. I could start typing here. See it? It's right there. Okay? Once I declare it in the header, the whole class has access to it. Once I declare it in a method, only the method has access to it. To strengthen this statement, or this claim that I'm making, the claim is what actually is happening, we're going to look at, do we have anything that returns anything here? Yeah, here we go. Pardon me. This cold has got me a bit down. This method here returns an integer. Right? It's an integer type. That integer type only exists here. Right? It says NS integer type called number of sections in table view. If I type, a return on that one, and of course UI table view. If I type table view, right, which is declared here, I only have access to table view within this scope. I don't know if I can type number of sections. I would think I would, but it's the method itself, so I don't think it's accessible. No, it's not. It's just telling you here that this method, number of sections in table view, returns the integer, which it does here. But what I'm trying to get to you to understand is that this table view, right? This variable here is only accessible because it's declared here. If I tried to type outside of that, let's see, well, here's one here. Table view, number of rows and section. I probably could get it here. Let's see what happens. Yeah, it's there too, because in this method it declares it here as well. I'm going to try to find a method without it. This one also declares it here. It's going to find it here. Let's go to viewed load. You shouldn't have it available here if we're right. It's not. You notice table view isn't available. Why? Because it's not declared within this method. And I would not want to declare a table view variable here, because these variables would do exactly what our integer did here and say here, and would hide the instance. So what we're learning here is something important. Declare only the variables you need within the class, because the whole class has access to them. Alright? I'm also going to get the table view here, by the way. Right? Watch. Yeah, see it? Right there. I'm also going to get what? Not only the table view, but this index path. I should see it. And there it is. So, we're looking at something called scope. Scope is telling us when variables exist and when they don't. This is very important as a developer to you. Another thing about the scope of variables. These variables here from the app delegate don't exist if this doesn't exist. Look what happens. I'll comment out the import of that, and it's saying I can't find them. They don't exist. In fact, if you click on here, property qual array not found. Whoops, I got some breaks in here. I gotta throw these out. Get out of there, get out of there. Thank you. Okay. Whoop, I did it again. Okay. So, in order for us to find them, I have to uncomment that out. And there it goes. It finds them now. So, the scope of variables has a few important things going on. The first is when they're declared, where they're declared, and if there are references to them. So we're going to put that right in our little thing here for our session here. All right, here we go. Variables exist when they are declared we're going to copy this line here, where they are declared, there are references in many cases. So as a developer, what you have to know, what you need to know is this, is that without declaring them at the right time, in a proper place, and where the references are, those variables will not be accessible to you. Okay, let's talk about another kind of variable or object. The outlet and of course the action. These are two important things, and they're variations on the same theme. Go into the qual picker here. You saw it in action here, button pressed, right? The action is declared outside of the scope of the interface braces. What is that telling us? It's telling us, again, where. Right? I'm just going to say here, okay, class, method, or method. Two possible places a variable can be declared, right? There's other ones too, but for our purposes right now, the action method here is declared outside of the braces. It's its own method. We look over here. Here it is. It only exists here. The information in it only exists here. Nowhere else. Not in the class, not anywhere. We go over to the nib. This button requires an action. That's why we declared it here and implemented it here. If we didn't have any action for this, we could press this button until the sun burned out. It would never do anything. When we create or declare the action and implement it. Alright. That's the first step. We still could press this button, the cows, the sun would burn out, the cows could, we could go blue in the face, it wouldn't matter. Nothing would happen. We have to link it. That's the second part of it. We linked it to the touch up inside event. So we have to have a method that will carry out an action when we press the button, implement, and declare and implement, and then we have to connect it. If we don't connect it, the user won't be pressing that button forever, and nothing will be happening. Similarly, but differently, the outlet. Notice where it's declared in the braces. What does that mean? Well, we go back here. When would be, let's say, declared in interface statement. That's actually where, but declared trying to think of an example of a when here. It's mostly, okay, well, declared first, we'll call that, and we'll say .h file, right? Or declared as needed. Declared and implemented as needed. And that will be in the .m file. Okay. So, and this is telling you here, again, number one, this corresponds to the class, and this is going to be your methods, alright? And the references, we're going to just put on that one, are in the .m file. .m has the import. We're going to call this, say, the import statement there. And another one too, by the way, is the @class, and that's in the .h. So when these references exist, we have access to the class. We're going to go back to this and show you what we mean. In the add_qual picker, if we don't define the class demo app delegate, this variable cannot be declared. There's no reference anywhere else to it. If I take this out, look what happens. I can't declare that variable. So you need proper references. As a developer, you have to know that. Alright, so let's go back to finish this off, the outlet. The outlet, again, is the same flavor of the action, but it's in reverse. If we go to the add dwarf nib, we didn't have any button or any key to press. We had this text box, and when the user types on the keypad and the information goes in there, without an outlet, that information can't be processed. Alright? Can't be processed. And so we need an outlet, and we need to declare it, and then we need to implement the outlet. Now, mind you, because we declare it here in the braces, we have full access to it throughout the whole class. And notice, we have here, right? There's all kinds of, let's go up a little bit, here, all kinds of access to that outlet. And notice that's the first thing, declare and implement and use it wherever we have to use it. The other thing is the big one again. Oops, sorry. Wrong one. There we go. We have to connect it as well. We have to have it as a referencing outlet to the file's owner. Alright? The file's owner, just to enforce this again, I always do this, it means that we find it in this class. So, again, whether it's an action or an outlet, we have to have something to receive or send it from the interface. And then we have to connect it with the code, which we do here, whether it's in a referencing outlet or whether it's in a touch-up event or whatever event it is. This being said, believe it or not, the picker is an outlet. We saw that where? Here. Don't believe me? Well, it's declared as a variable. Wait a minute. Hold on a second. Go to the iQual picker. Actually, as a variable and then as an outlet as well. Because it is an outlet. It receives action from the user at where? At the nib. Want to go one step further on this? You should have realized this to begin with, but isn't our navigational controller an outlet as well as the initial window? Don't believe me? Come to your root view. I'm sorry, your demo app delegate. Had the window and the navigation controller. They were outlets. Now notice where they're declared. This is interesting. They're interface builder outlets. Whereas in our picker, we had, in our dwarf controller, we had also an interface builder outlet within the braces. And notice that we didn't want this window and navigational controller accessible from the whole class. Though it is. As you notice, it is. We've synthesized it here, and then we have it here, right? We access it here. We release it over here, and so on. So, an outlet, where even if it's declared outside the braces, can be accessed from anywhere in the class. And it's an outlet. Let's go over to the demo app delegate here, close this one, and show you outlet, variable, outlet, and variable, right? And those outlets, again, interact with the user. So to close this out, whoops, sorry. Close this out. Outlets receive user interaction, and actions process user interactions. So, right? So this receives, receives user interaction, and an action processes it. So, an outlet could be a text box. Actually, let me put this in here. Wait a second. Text box, right? As an example. of an outlet. A window, the app window. We saw that. The nav controller. We saw that as an example. Picker, right? Picker's an example. Okay. The actions are, we've seen a touch, a button with a touch up inside. Or one might be a swipe or some sort of tap on a key. We've seen it where some sort of tap, any action the user, right? And these require methods. Okay, so this is our XCode 101, part 1. Variables. Oh, sorry. Hang on a second. Oh. Variables and variables, I'm sorry, objects, outlets rather, and actions. Okay, and so when you see code written for the variables and the outlets and the actions, keep these things in mind. Majority of what you're going to be doing is based on all of this. Alright? If you need to take a URL from somebody, having them type it in a window, that requires an outlet. If you need to press a button to accept that URL and open up a web view, the web view becomes basically an outlet, and the button becomes the action as well. So you have the text box, the web view are the outlets, and the button is the action. So keep all this in mind, and when we return next time, I want to get back to the tutorials. I want to finish off on our picker. Really the only thing that's left is on the tutorial, which will be tutorial number 17, I believe, will be we want to check to see if the user has added a value already, or if the value is present, I should say. And if it is, tell the user it's present, you can't add it. So with that, keep this important information in mind, and I'll see you next time. Take care.